Assalamualaikum and good morning to our panels. Before we start, I would like to say thank you to my supervisor, Sir Noor Azazi bin Natiman, for providing assistance and guidance throughout the completion of my project. So, I'd like to quickly introduce myself. My name is Mardhiyah binti Muhammad Azizi from Class 3 BMMM, Section 11 with matrix number B0918102440. As a presenter this morning, my goal today is to help you to understand about the development of vibration monitoring using Arduino Mega. Introduction. Over the years, Arduino has used thousands of projects from simple houseware to sophisticated tools. It proves that Arduino hardware and software help designers and amateurs, for example, in creating interactive objects or surroundings. Firstly, Arduino is a microcontroller that can be easily programmed, erased and reprogrammed at any moment. The reusability, cost-effectiveness and reliability of this microcontroller have proved to be most effective. Secondly, Arduino can act as a brain by accepting the outputs for various electronics devices into and controlling them. Next, it is able to receive and transmit internet information with the use of Arduino Shield modifications. In addition, this project also focuses on vibration monitoring utilizing the vibration sensor and acoustic sensor. Furthermore, this project is separated in three different phases. Firstly, the development of software. Secondly, code programming, and thirdly, manufacturing system hardware. Problem. The idea of this project came due to limited access of Arduino prototype with certain budgets, as students were lack of funding when doing their research for their final year's project. Arduino was made for student-friendly price rather than purchasing the expensive hardware in the market, even though they were much more precise, accurate, and compatibility. It is not a reason to create a project with affordable price. Next, the usage of this Arduino can be customized and students can do their own version of DIY, do-it-yourself microcontroller. They can use it again for their next project with different components, and they were able to create this project from scratch with friendly budget, as Arduino proves again that it is cost-effective, reusability, and dependability. Next, this project was made to monitor the presence of vibration and acoustic in the engine. With a small and petite design and size, this Arduino can be placed at any part of engine, including the smallest space. There are numerous engine kinds, but it has not yet been chosen what kind of engine this Arduino would like to monitor, because I plan to attach this Arduino on the engine surface. The objective of this project is, first, to design Arduino Mega project and to develop software using Integrated Development Environment (IDE) and Blink application through smartphone device from scratch, and manage to create coding for this project. Second is to verify vibration and acoustic analysis from Arduino Mega to monitor the engine using wireless system and compare with the existing wireless Arduino project. And thirdly, is able to run this project smoothly when monitoring the engine's vibration and acoustic. The scope of this research are, first, focusing on vibration and acoustic analysis. As I mentioned before, this project was separated into three phases. The first phase is the software was utilized to develop coding in the ATmega2560. Second phase is to identify vibration signal of rotating component prior to loading to ATmega2560 and declare input-output in the IDE. And last phase is comparison with standard and existing technique of the hardware fabrication and form into prototype. Methodology. In order to create a customized microcontroller, firstly, all of the hardware components needed would be the breadboard. This breadboard was designed to be a housing for the ATmega2560, vibration sensor and analog piezoelectric module sensor, microphone and ESP8266 Wi-Fi shield module. This project focuses primarily on the wireless built-in system in order to ensure that data from the engine's vibration and acoustic can be acquired from a distance when compared to the traditional methods. Secondly, in the sensor interface software, the microcontroller program code and the Blink applications code were two important components. The ATmega2560 managed the associated sensors, including interpreting the code received. The data speed to read and storage ESP8266 sensor readings and when to transmit blink sensor readings through iOS or Android was all defined by determining the sensor rate. Blink was chosen for this project because the platform allows individuals to create interfaces rapidly with iOS or Android to manage and monitor their hardware projects, and all the information on all microcontroller connected sensors should be displayed. Next is prototype. From this project, students must build and debug code for their hardware interfaces and create a complete system. Every hardware component instructs a control directly via the IDE in order to make the data legible during the project's execution. The IDE and monitoring vibration reading can be assembled and uploaded to the cloud after getting the data. This project is related with vibration and acoustic that occurs in engine, which students can monitor the parameter and can be extract analysis results. The ultimate results of input-output are shown. Thus, the purpose of this methodology can be achieved as students are able to embed systems relates to design, co-design, prototyping, optimization, validation and testing of hardware software. As you can see from this schematic diagram, this is what I want to achieve for this project. Firstly, create a software coding. In this process, we will construct a command for each ATmega2560 and ESP8266 Wi-Fi Shield module. And after that, I will develop the Blink software on smartphone device, which it will receive commands and send them to microcontroller ATmega2560 and ESP8266 to perform correct tasks. If this process can stimulate the circuit, I will proceed with second phase, which is create the IDE on ATmega2560. Moreover, the ESP8266 will transmit the vibration and acoustic sensor from the engine directly to the Blink apps. So from the Blink apps, we can monitor the engine vibration and acoustic from a distance at any time and everywhere, compared to the traditional method where we will monitor the vibration from the PC only. From previous research work, the prototyping with Arduino, wireless sensor network, and remote monitoring are my reference to complete this project. This project was inspired from previous Arduino project and existing technique, which I will make a comparison with my project. I will explain in the next slide, which is the citation for my project. For this project, I have made lots of research and I decided to use Arduino Mega as my main components. There are different types of Arduino and I choose Arduino Mega 2560 because of its specification. The Arduino Mega 2560 have a big dimensions, 16 MHz powerful CPU power and processor, 54 input-output capability with large memory size. For Arduino Shield, I choose the ESP8266 as a Wi-Fi Shield module because it is a low-cost, compact size and integrated device interoperability. It is an embedded device that can be connected and data transferred via the Wi-Fi antenna on the module. Next is sensor compatibility. For this project, I use two types of sensor, which are the vibration sensor and analog piezoelectric sensor for acoustic. The vibration sensor can help to track vibration data in real time and identify possible failure locations. For acoustic sensor, it diagnoses the probable failure by measuring the noises and frequencies emitted by equipment and comparing them to known failure frequencies. Acoustic tries to prevent failure by constantly monitoring the status of equipment. So I decided to use these two because I would like to monitor the vibration and acoustic present in the engine. For my first reference is Arduino and LabVIEW in Educational Remote Monitoring Applications, written by Dila Kalenui and Mihaela Lascu. The summary for the article is Arduino used for remote monitoring of selected environmental parameters, designing and implementation of the monitoring circuitry, programming for both LabVIEW and Arduino, understanding 5 concepts, and using mobile device for parameters monitoring. I choose this article because it mentioned about the education remote monitoring, and the article is my inspiration to run this project using the Blink application. Secondly is Introduction to Arduino in Digital Electronics for Musicians from Draimonitis A. This book shows how to create coding on each hardware components for software. This book is very useful to newbie or students who are not familiar with Arduino, and a good guidance for them to learn. And lastly, is a systematic literature review on prototyping with Arduino, applications, challenges, advantages and limitations by a group of authors named Hari Kishan Kondaviti, Nandish Kumar Kumaravelu, Sunny Dayal Vanamtina, Sudai Elisamate and Susila Vapangi. In this journal, it intensively analyzed and compared existing primary studies in prototyping with Arduino. It also explains the Arduino applications, challenges, advantages, and also limitations. This journal is very helpful for me, and I learned a lot from this journal. Through the research for this project, it is found that the development of Arduino is quite challenging and it takes time for new users to learn and develop due to its complex structure. They need to be very conscious of the hardware also, as they are running and understand their commands first before they can grasp the system. Moreover, this project may buy some time to complete because there are few hidden features inside the Arduino itself. Kondaviti mentioned that new findings require time to become professional or hobbyists in the hands of most users. So, as a student, this is a challenge for us to completely understand the Arduino itself. Lastly, one of the problems that the student will face during the process of the development of this Arduino Mega will require efforts to accomplish tasks such as scheduling and database storage. This wastage of time is usually due to the low processing power and small storage space. Besides, the interface of analog and digital sensors with an Arduino board has to develop carefully, as it may result in initial manufacturing phases and wireless module for communication with sensors. In conclusion, this project was inspired from existing systems which are used in monitoring engines vibration using a wireless system. Students are able to confront hardware subjects related to sensors and signal conditioning from the vibration and acoustic. Students are able to learn and had the opportunity from the self-learning programming with dedicated Arduino functions. Besides, this project can help students to develop their own do-it-yourself DIY monitoring Arduino project with low-cost budget. This project is appropriate to practice because it can control from a distance. Thus, DIY monitoring Arduino can also analyze other monitoring scales such as humidity or temperature, for example, because this project is a customized Arduino. So, for future development, this project will focus on finalizing this system. As for the first task, it will focus on analyzing the vibration and acoustic spectrum from the engine. This project is quite helpful because it can be monitored and controlled from the smartphone itself using the Blink application. So everyone can access the data and monitor the spectral analysis from afar without worry. So that is all from me. Thank you very much.